Hey everyone, welcome back for another deep dive. It always gets me thinking about how AI actually learns. It's incredible. Today we're taking a look at a paper that really made me question some things.
Oh, yeah. What's that?
Well, it's all about these large language models, the LLMs you hear so much about, and how they use external information. Like we always say, knowledge is power, right?
Right.
So this paper dives into whether giving these LLMs access to more information actually makes them smarter. Like tons of data, better answers.
It makes sense to think that, right? More information should equal better results.
Exactly. But this research kind of throws a wrench in that idea.
Oh, how so?
It actually found that there's a point where, get this, cramming in more data can actually make the LLM's performance worse.
Really? That's so interesting. It's like that saying, too much of a good thing. I'd love to hear more about this.
Yeah, right. It's like information overload, even for AI. The paper calls it the inverted U of performance. Imagine this. You're baking a cake, okay? You've got your grandma's handwritten recipe, the one that turns out perfect every single time. But then someone dumps 50 other random cooking instructions on the counter, some for cookies, some for stir fry, who even knows what else? Just a jumbled mess.
Oh, I can see where this is going. All those extra instructions would be so distracting.
Exactly. Suddenly, it's way harder to focus on your grandma's recipe, the one that actually matters. You're much more likely to mess up the cake, even with all that other information right there.
So you're saying even if the LLM has the right information, all those key ingredients for a perfect response, all the extra stuff can actually distract it from using that information effectively.
That's exactly what they found. And it gets even more interesting. The research goes beyond just the amount of information and highlights a much sneakier problem, something researchers call hard negatives.
Hard negatives.
Uh,
Okay, now you have to explain that one. That sounds serious. What are those?
So these hard negatives, they're like those fake websites that look totally convincing but are actually full of misleading information. You click on them thinking you've hit the jackpot, but really they're just trying to trick you.
Oh, I've totally fallen for those before. Those are the worst. So instead of just being random, irrelevant stuff, these hard negatives are disguised as helpful information. So sneaky.
Exactly. They're like wolves in sheep's clothing, just waiting to trip up the LLM. And the worst part is they can introduce subtle biases or even lead the LLM down a completely wrong path without it even realizing it's happening.
Wow. I'm starting to see why simply throwing more information at an LLM isn't the solution. This whole hard negative thing still feels a bit abstract to me, though. Do you have a real-world example of how this plays out?
Absolutely. The authors used this fascinating example about wind patterns in Nigeria. They asked, when does the southwest wind blow across Nigeria? Seems straightforward, right? So a good retrieval system would search for information about wind patterns in that region specifically. Makes sense. But here's the thing. Different retrieval systems might pull in different types of info, even if they're all about wind in Nigeria.
Okay, so even if they're all on the right topic,
Yeah.
the information itself could be vastly different.
Exactly. Like one system might find information about the southwest wind specifically during different seasons, directly relevant to the question.
Wait.
But then another system, even a strong one, might pull in passages about something called the harmattan winds.
They're harmattan winds. I've never heard of those.
Right. So the harmattan is this dry, dusty wind that also affects Nigeria. It's related, but it's not answering the specific question about the southwest wind. And that's where things get messy.
Ah, I see what you're getting at. Like if I asked you for a book recommendation on, say, ancient Rome, you could give me a bunch of great novels set in that era. But you could also hand me some history textbooks about the Roman Empire. Both are technically related to ancient Rome, but one is way more helpful to me depending on what I'm actually looking for.
Such a good analogy. And for the LLM, imagine getting hit with all this extra info about the harmattan winds when it's trying to zero in on the southwest wind. It could totally confuse it, leading to inaccurate or irrelevant responses. It's like those extra cooking instructions messing up your perfect cake recipe.
Wow, never thought of it like that. So you're saying our awesome, superpowered AI search engines can sometimes lead us down the wrong path.
That's what this research is suggesting, yeah. It
Good.
definitely changes how I think about AI and information. But if the traditional ways of evaluating these systems aren't catching these hard negative problems, then what can we even do about it?
That's the big question, isn't it? And luckily, this paper doesn't just point out the problem, it offers some really creative solutions.
So we're talking about how just throwing more information at an LLM isn't the answer, especially with those sneaky hard negatives lurking around. But how do we actually fix that? Can we make these LLMs smarter about the information they're processing?
That's the million-dollar question. And the good news is this paper gives us some really clever solutions. Some are actually simpler than you might think, like this idea of retrieval reordering.
Retrieval reordering. Okay, now you have to explain that one. Sounds like something I do with my sock drawer.
Well, imagine this. You've got that mountain of cooking instructions, right? Well, it turns out LLMs, kind of like humans, tend to pay more attention to what's at the beginning and the end.
Right, like if I'm reading a really long report, I always focus on the intro and conclusion. Everything in the middle kind of blends together.
Exactly. Researchers call that the lost in the middle effect. And that's what retrieval reordering takes advantage of. So instead of giving the LLM this jumbled mess of info, we arrange the retrieved passages strategically, putting the most relevant stuff at the beginning and the end, where the LLM is most likely to pay attention.
So it's like we're highlighting the most important pages in that massive report. And does that actually improve their accuracy?
You bet. Especially when we're dealing with a lot of retrieved information, it's like we're giving the LLM a roadmap,
Yeah.
so it knows exactly where to focus its energy.
Wow, that's incredible. Such a simple tweak. But the paper also talks about some more complex approaches, data-driven approaches. This is where we actually start training the LLM, right?
Exactly. Think of these training methods as giving the LLM the tools it needs to be a more discerning reader. And we can do this in two ways, basically.
Yeah.
Implicitly or explicitly. So implicit training. That's like giving someone a ton of news articles and being like, okay, now you figure out which ones are credible and which ones are trying to mislead you. We essentially just let the LLM learn by doing.
So instead of giving it specific rules, we're letting it learn from experience, like figuring out how to spot those fake news articles by just encountering tons of different examples.
Exactly. With enough exposure, especially to a diverse data set with those hard negatives, the LLM can start to pick up on those patterns, those subtle clues that help tell good info from bad info.
And what about explicit training? Is that more like we're actually teaching it specific fact-checking
You've
skills?
got it. It's more like, here's a checklist of things to look for when you're evaluating information.
Yeah.
We're teaching the LLM to actually reason about the info by explicitly pointing out those relevant passages and maybe highlighting any inconsistencies or biases.
So we're basically teaching it to think critically about what it's reading. Like, don't just blindly accept everything you see, LLM.
Exactly. It's all about empowering the LLM to be an active, engaged reader.
That's so cool. Are we basically teaching these LLMs to think more like human researchers then?
In a way, yes. We're giving them the tools to analyze information, identify those important connections, and then hopefully come to more accurate and insightful conclusions.
So both implicit and explicit training sound super promising, but is one better than the other?
It's not really about one being better than the other. It's more like understanding the strengths of each approach. So implicit training, that seems to be really helpful in making the LM more robust to those pesky hard negatives. Whereas explicit training with that added layer of reasoning, that tends to lead to a deeper understanding of the connections between different pieces of info.
So it's all about finding the right tool for the job, depending on what we want the LLM to actually do.
Exactly. And there's one more thing the researchers found that plays a huge role here: data diversity.
Okay, so not just more information, but a wider variety of information. Why is that so important?
Well, think about it this way. If you only ever read one type of book, or only got your news from a single source, you'd have a pretty limited view of the world, wouldn't you?
For sure. I'd miss out on so many perspectives and ideas.
Right. And it's the same with these LLMs. The more diverse their training data, the better they'll be at actually generalizing their knowledge and applying it to new, unseen situations, exposing them to all sorts of different writing styles, different areas of knowledge, even conflicting viewpoints. All that helps them develop a more nuanced and comprehensive understanding.
Wow, that's amazing. We're basically teaching these LLMs to be curious, open-minded learners, just like we should all aspire to be.
Exactly. We're helping them appreciate that huge, complex world of information, just like we do.
This whole conversation has really changed how I see AI. And honestly, just learning in general. It's not just about memorizing a bunch of facts, it's the context, being able to think critically and pick out the good info from all the noise.
Absolutely. And this research really drives that point home. We need a smarter, more strategic approach when we're designing these powerful LLMs. It's not enough to just give them access to endless information. We need to actually give them the skills to use it effectively.
It's It's like giving someone a library card but not teaching them how to actually use the library. They might find a cool book or two, but they're missing out on all the amazing resources.
That's a great way to put it. And that's why really understanding things like retrieval reordering, those tricky hard negatives, even just data diversity, it's all crucial. We want LLMs to be intelligent, discerning users of information, not just passive consumers.
Which brings us back to that thought-provoking question from the paper. Imagine you're building an LLM for a very specific purpose. Let's say it's for doctors, to help them keep up with the latest medical research. Where do you even begin to curate the training data for something like that?
Now, that's a great question. It really makes us think about all this practically. So, in the case of medical research, you'd want the LM to be exposed to a wide range of sources, right? Published papers, clinical trial data, maybe even some anonymized patient records, with all the privacy considerations, of course.
Of course. But it's not just about the raw data, is it? We have to think about the context too, right?
Absolutely. Alongside those research papers, we'd want to give the LLM information about things like medical ethics, maybe the history of certain treatments, maybe even some social science papers about how doctors actually make decisions.
That makes so much sense. It's like we're giving the LLM this well-rounded medical education, not just a crash course in here's how to read a research paper.
Exactly. And we can't forget about those hard negatives. We'd want to include examples of well-designed studies and studies with flaws, maybe even misleading results. So the LLM learns to really critically evaluate the research, just like a human expert would.
That's so important. And this principle applies to any field, really, not just medicine. Like, if we built an LLM to translate, say, ancient texts, we wouldn't just feed it dictionaries and grammar rules, right? We'd want to include historical context, cultural insights, maybe even examples of past mistranslations so it can learn from those mistakes.
Exactly. True expertise comes from a deep, nuanced understanding, not just knowing a few facts.
For sure. And that's what I find so exciting about all this research. It's not about making these LLMs bigger or faster. It's about making them smarter, more insightful, ultimately more valuable to us.
I totally agree. We're pushing the boundaries of what these amazing learning machines can do.
It's a really fascinating time to be working in this field. Thanks so much for taking this deep dive with us today. This was awesome.
My pleasure. It's always great to chat with you.
And to everyone listening, thanks for joining us. We'll see you next time for another deep dive into the world of knowledge and AI.